Do you feel the vibes?
Hey guys, welcome to Mrs. Malikian's YouTube channel. I hope you liked that intro just now. I'm using it for the very first time today. And I want to give a shout out to Sam K from A Period for creating that for us. Remember, if you like this video, please hit like and subscribe at the end. All right, so let's get right to it. We are talking about 8.2 today, adding and subtracting rational expressions. So let's do it. Right, so we know how to add fractions and we know how to subtract fractions. And remember that if you want to do that, you want to find the least common multiple, or the LCM. And it's the same sort of situation when we are adding polynomials. So in order to add or subtract polynomials, they must have the same denominator. So we want to create a common denominator. All right, let's go with this first example and start very slowly. So I have 5/6 plus 4/9, and I want to find their common denominators. All right, so you're already thinking it's got to be 18, right? I know you are. Okay, but let's pause for a minute and think, why is it that we make that an 18, right? So this denominator, 6, right? The factors are 2 times 3, okay? Now this denominator, 9, its factors are 3 times 3, or I can write it as 3 squared. So now for the common denominator, basically I want to find a number that both the 6 and the 9 can go into. That means the number that I find for the common denominator has to have common factors in the 6 and in the 9, right? So all of the factors of 6 and all of the factors of 9 have to exist in that 18 that we find. That's why I pick 2 from here, right? But now I'm stuck with, because I've got a 3 and a 3 squared. Between the two of those, I pick the one with the higher exponent, 3 squared. Okay, so now that becomes 18. And so in 18, I find all of the factors of 9 and all of the factors of 6. Okay, all right. So now I know my denominators are 18. Well, what am I going to do to the fractions? I want to multiply the 6 by whatever will make it into an 18. So I multiply that by 3. And of course, I have to do the same thing to the top. So there I get 15. Now the 9, I need to multiply by 2. So I get an 8. And finally, that gives me 23/18. Fabulous. Okay, so now let's do the same thing here. Remember what we did in the case of the 5/6 and the 4/9? I kind of looked at the factors, right? So let's take a look at the factors of the denominators here. In this case, the factors of that denominator are x minus 2, x minus 1. The factors of this denominator are 2, x squared minus 1, which when I factor further, it's x minus 1, x plus 1. Right, so now what is the LCD of this, right? For the LCD, I want to take a sampling of each of the factors. So first and foremost, there is a 2 here. So I want to take a 2, and then I've got an x minus 2. So I want to take an x minus 2. What else do I have? I have an x minus 1 that appears in both of these. So I take one of those. And lastly, I have an x plus 1. So I take one of those, right? So do you see how each of the denominator's factors exist in this one? So in the first denominator, x minus 2, x minus 1, yes, that exists here. In the second one, 2x minus 1, x plus 1 also exists in there. Fabulous. All right, so let's go over here, and we're just going to find the LCM, right? it's the LCM that becomes their common denominator. So the least common multiple of each set of polynomials. Okay. Let's take a look at the coefficients first. So in the case of the 15, right, that's 3 times 5. The 16, that's 2 to the 4. You want to break it down into its most elemental base and always write them in terms of powers. And then this one, the 20, is 5 times 2 squared. All right. Right. So from the coefficients, what am I going to take? Well, it looks like there is a 3, there is a 5, and then there is a 2 to the 4. So that's going to be the coefficient of my LCM. Right. So now let's take a look at the A's. I got an A square and an A cubed. Of course, I take the one that has the larger exponent. As far as the B's go, I have a B to the 5. So I'm going to take B to the 5. And then lastly, I have a C cubed, a C squared, and a C to the 6. That's what I'm going to take. All together, that becomes 240. A cubed, B to the 5, C to the 6. Okay. So that's the LCM. All right, so let's take a look here. Of course, we're going to factor first. So here we factor out an x. I get x squared minus x minus 2. I factor some more. I get x minus 2, x plus 1. Okay, this one. When I factor, it gives me x minus 2 squared. Fabulous. So for the LCM, right, there is an x here that I'm going to take. All right, I have an x minus 2 and an x minus 2 squared. I'm going to take the square. And then lastly, I have an x plus 1. That's my LCM. Awesome. Okay, so how do we add and subtract rational expressions? Well, first you want to find the least common denominator, which we just learned how to do. That's the LCM. And then we want to rewrite it with the LCD. So basically just make a common denominator. All right, let's do it. So here, let's see what the LCD is going to be. Between the 6 and the 14, I'm actually going to have to take a 42. Then I have an A squared and a B squared. Okay? Right. So what am I going to multiply the first denominator by? In order to make this into a 42a squared b squared, I need to multiply by 7a squared b, right? So 7a squared b. Okay, and the second one, I'm going to multiply just by 3. Multiply by 3. All right. So now I have, in the denominator here, 42a squared b squared. And then here I got 35 a to the 4b plus 42 a squared b squared. Hey, look at that. They're the same. And then the numerator is a 27. So at the end of the day, I have one denominator, right? When I add them, now I have a common denominator, which is 42a squared b squared. And when I add the numerators, I get 35a to the 4b plus 27. And if this doesn't look, conventional like all the other fractions or rational expressions that you've seen, that's okay, because you know what? Who are we to judge? Right, let's move on. So here, when I factor this, I get a denominator of 3 times x minus 5. And then here, 6 times x minus 5. Fabulous. So my common denominator, right, is going to be, I'll write that down here, 6x minus 5. Okay. So to make this first denominator into the common denominator, I need to multiply by 2. So multiply by 2. And when you do that, please, please, please do me a favor and put that in parentheses. We don't want to, misinterpret things. And then the second one, I actually don't need to multiply by anything. So I'm going to get 2x plus 20 minus, in parentheses, 3x plus 15. This is 2x plus 20 minus 3x minus 15 all over 6x minus 5. So here I get negative x plus 5 over 6x minus 5. Oh, but wait, what is negative x minus 5? Isn't that the same if I write it in reverse order? Isn't that the same as positive 5 and negative x, like that? Oh my God, it totally is. So now 5 minus x minus 5, they cancel, but I have a minus 1. So at the end of the day, this is negative 1 over 6, right? Plot twist. I mean, look at this. Look at what we started with. And who would have thought that we would have ended with negative 1 over 6? Crazy. Okay. Let's take a look at this one. So first we factor x minus 3, x plus 2. Factor out of 5, I get an x plus 2. All right, so what is the LCD going to be? It's going to be, let's see, I need to take a 5, an x minus 3, and an x plus 2. Okay, so to make the first denominator the same as this, it needs to be multiplied by a 5. So I multiply that by a 5. The second one needs to be multiplied by x minus 3. Okay, so let's see what we got here. 5, x minus 1, minus 4, x minus 3. So let's not get too overzealous here, and don't skip steps. You've got negatives all over the place. Just take another second or so to write things out, right? So we're going to distribute 5x minus 5 minus 4x plus 12 over 5 x minus 3 x plus 2. Please don't waste time multiplying out that denominator all over again and undoing what you've done in the first place when you factored, okay? All right, so 5x minus 4x, that is an x, minus 5 plus 12, that's a plus 7, over 5, x minus 3, x plus 2. And if that's not a beautiful fraction, I don't know what is. All right, let's go over here. We're going to factor this one. So that becomes, let's see, 4x and x. And actually, I can put a 5 here. So that becomes 20x plus 1x, like this. Oops, plus 1. So I got a 4x plus 1, x plus 5. Factor out of 3, 4x plus 1. Okay, pro tip. If you factor out a 3 first here, right, if you did that first by chance, and you get that 4x plus 1, that kind of gives you a hint that you're going to have another 4x plus 1 over here, right? Because, I mean, listen, these are kind of created for that purpose. Right, so my LCD is going to be 3, 4x plus 1, and x plus 5. Right, multiply the first fraction by a 3, so we're going to multiply that by 3 as well. Second denominator needs an x plus 5. Okay, so let's go. I have 3, x minus 8, plus 6, x plus 5. 3x minus 24 plus 6x plus 30 over 3, 4x plus 1, x plus 5. Right, so this is 3x plus 6x, that's 9x, plus 6, that was good enough, over 3, 4x plus 1, x plus 5. All right, are we done? No, because just when you thought you were done, you realize you can factor out a 3 from here. So I get 3x plus 2 over 3, 4x plus 1, x plus 5. And now that the numerator and the denominator both have a coefficient of 3, those actually can cancel. So I am left with this very, very cute, simplified 3x plus 2 over 4x plus 1, x plus 5. Okay, so you're probably going to ask me, Miss Malikian, do I need to put parentheses around the 3x plus 2 in the denominator? I'm sorry, in the numerator? The answer is no. The numerator doesn't necessarily require parentheses, but obviously the denominator does, right? And your final answers must be simplified completely, all right? Like this 3 over here needs to have gone away. Fantastic. Right. So what if you have complex fractions? We were introduced to complex fractions in the last lesson, but over there we didn't have a sum or a difference in, like the numerator or the denominator. Now we do. So there are two ways of doing this. I'm going to show you method 1 first. Okay, so here's method 1. For method 1, you basically work as, one mini problem on top, another one at the bottom. So it's very important for this one to determine where the main fraction bar is and to draw that out first. So now you have literally like an upper story and a bottom story of this building, and you can just work, apartment by apartment. Okay. So in the numerator here, the common denominator is going to be AB, right? I take an A, I take a B. So what am I going to multiply these by? Well, the first one is going to get multiplied by a B, and the second one by an A. So I'm going to get B plus A. Wonderful. The bottom one, this is a 1. So my denominator between the B and the 1, the common denominator is going to be a B. So I got to just multiply this by B, right? So I get 1 minus B over B. Now, remember how we work with complex fractions. So this is the first one. Oops, let me color code. B plus A over AB times the reciprocal of the second one. So B over 1 minus B. Now, 1B, 1B cancel. So what do I get left? B plus A over A times 1 minus B. And again, do not cancel those A's, right? Because the A on top is being added to B plus A. So that's method 1, right? We have the main fraction and we're working top and bottom as mini problems, and then we combine this way. Right, so let's talk about method 2. Okay. So for method 2, here's what we're going to do. Take a look at the fraction in the top, right? So take a look at the upper story. The common denominator here between the two of these is an x. In the bottom, the common denominator is xy. So you have to basically take the common denominator of all of these together, right? So the x, the y, and the x. When you do that, the common denominator becomes what? xy. So this is like this mega common denominator, right? xy. So now, here is what you do. You have to multiply this entire upper story by xy, and you have to multiply the entire bottom story by xy. To make it simple, let's say we're multiplying by xy over 1. Okay, so where is my main fraction bar? It's still here. Okay, so take a look at what we're going to do, guys. Be careful here. I'm going to distribute this. So xy times 2 over x, right? What happens? The x's cancel and I get 2y. Minus xy times 1, xy. Oh my God, the denominator completely went away. Of course it did, because I multiplied through by the LCD. Okay, it's like black magic, right? So let's multiply this. Xy times 1 over y. These y's will cancel, so I'm just going to be left with x. Distribute to this one. Minus xy times 3 over x. The x's cancel again, and I get 3y, right? And that's it. We're done. We are done. Okay, now, isn't that easier? I mean, honestly, I have to say, for a very long time, I was like in the school of method 1. Now I can go back and forth, right? I can go back and forth. Both of them are equally my favorites, and you just have to choose which one you like more. Right, so this one, you notice here, you can factor out a y from the top. Okay, if you want to do that, that's fine. This is still x minus 3y. It is not necessary to factor out that y, because in doing so, you are not going to be able to cancel it out with something in the denominator, right? So both of these are okay. All right, fabulous. Okay, everybody, thank you so much. And you can go ahead and start on your homework.